Hello and welcome to the Magic of Mathematics channel. My name is Manohar Murthy and you are watching one amongst a series of videos exploring the world of mathematics.
In this video, I intend to examine the question, how does one make sense of non-positive integer exponents? In other words, I will look at what to do when we encounter 0 as an exponent or negative integers as exponents. I will use 5 raised to the power 0 and 5 raised to the power negative 2 as examples of these two cases. I intend to show how to treat these two expressions. This should give a general idea of what to do when we have 0 as an exponent or when we have a negative integer exponent. I will assume here that you are familiar with how to interpret positive exponents. Let me write down the two examples that I will be using, namely 5 raised to the power 0 and 5 raised to the power negative 2. Let us first attempt to arrive at how to make sense of these two examples using our knowledge of positive integer exponents. From our knowledge of positive integer exponents, we know that 5 raised to a positive integer exponent, say 3, is 5 multiplied by itself that many times, in this case 3. If we try to apply a similar interpretation or meaning to our two examples, we don't get too far, as 5 multiplied with itself 0 times and 5 multiplied with itself negative 2 times don't make too much sense. Hence, it is clear that we will need to approach the task at hand differently. For this, I will use the interpretation of positive integer exponents to once again write the expansion of 5 raised to the power 3 as 5 times 5 times 5. I will use this expansion as the starting point for my argument. Let us see what happens when I divide the expression on the right hand side by 5. 5 times 5 times 5 divided by 5 will give us 5 times 5. From our knowledge of how positive integer exponents work, we know that this can be written as 5 raised to the power 2. As can be seen, dividing by 5 has resulted in the exponent decreasing by 1. Let us see what happens when I divide once more by 5. 5 times 5 divided by 5 will give us 5. And we know that this can be written as 5 raised to the power 1. Again, division by 5 has resulted in the exponent decreasing by 1. A further division by 5 gives us 1. If we want to express this as a power of 5, we can use our observation that division by 5 results in the exponent decreasing by 1 to say that our exponent should be 0. In other words, 5 raised to the power 0 can be interpreted as or is equal to 1. If I divide the right hand side again by 5, I get the fraction 1 over 5. Our observation that the exponent decreases by 1 each time I divide by 5 can be used to express this as 5 raised to the power negative 1. I will divide the right hand side one last time by 5. I can express this as the fraction 1 over 5 times the reciprocal of 5. When we multiply two fractions, we get a fraction whose numerator is the product of the numerators of the two fractions and whose denominator is the product of the denominators of the two fractions. 1 times 1 is 1, and we can use the interpretation of positive integer exponents to write 5 times 5 as 5 raised to the power 2. Therefore, our expression equals the fraction 1 over 5 raised to the power 2. Again, using the observation that each time we divide by 5, we end up decreasing the exponent by 1, we can interpret this as 5 raised to the power negative 2. Looking back at the interpretation of 5 raised to the power negative 1 as 1 over 5, I will write this 5 as 5 raised to the power 1. Let us now examine what we have done so far. 5 raised to the power 0 is 1. There is nothing special about the number 5. In other words, I could have used any other number instead of 5, say 4. Using a similar reasoning, I can arrive at the fact that 4 raised to the power 0 is also equal to 1, which leads us to believe that any number raised to the power 0 should be interpreted as 1. As a special case, let us see what happens if I use 0 as my base. In other words, we want to know how to interpret 0 raised to the power 0. As can be seen from the division done here, I will need to divide 0 by 0 to interpret 0 raised to the power 0, and since this is not possible, we say that 0 raised to the power 0 is not defined. This leads us to the fact that any non-zero number raised to the power 0 is 1. Let us now look at what happens when I raise a number to a negative power, or in other words, when my exponent is negative. We can easily see that there is nothing special about the base that we have taken for our example. Instead of 5, we could have taken 4 instead and used a similar argument. The key thing to note here is the relation between these exponents and these exponents. We know that 1 is the negative of minus 1, or in other words, negative of negative 1 is 1. Similarly, negative of negative 2 is 2. So, when we encounter a negative exponent, we need to find the negative of the exponent, or in other words, remove the negative sign so that we get an expression with a positive exponent, and then take the reciprocal of the expression so obtained. Taking an example of 4 raised to the power negative 3, we need to negate the exponent negative 3, leaving the base unchanged, thereby obtaining 4 raised to the power 3, and then take the reciprocal of the expression so obtained. If I do this, I will end up with 1 over 4 raised to the power 3. In this video, I showed how to interpret non-positive integer exponents. I hope you found this video useful. Thanks for watching.